Welcome everyone to this presentation. I'm Stefan Fercot. I'm living in Belgium, and I'm also known as pgStef. You can find me under that nickname on Twitter, on GitHub, and so on. I've been using Postgres since more than 10 years now, and I have always been interested in all the backups and high availability field. As Ilya said, I'm a big pgBackRest fan, and I'm currently working at EDB as database backup architect. So the talk today, I would be glad to share you about some insights about pgBackRest. I would like to go a little bit deeper as some just basic knowledge, but I first have to give back some basic functionalities reminder so everyone is at the same stage. And then we'll go through various advanced topics like where do I store my backups, how do I interact with the standby server, what is asynchronous archiving, and then what are the catch-ups and tips and tricks about diagnostic and monitoring. So pgBackRest, it aims to be a very simple and reliable backup and restore tool. It has been written in C, and the latest release in June was a 2.34. You can use it all locally or remotely, so you can operate two ways. And the process, the protocol of communication between the local and the remote process is a custom protocol and is using SSH. So let's start with the basics. The basics, well, the first thing to do is to install pgBackRest. Thanks to our great pgDG community, we get all the packages in the repos. So use the repos and use yum or apt-get to install pgBackRest. That's the easiest way. Then you usually have to configure your backrest. There is a configuration file, that's an ini style, and you have basically two parts there. The first part is the global part. The global part is where you will define all the settings that are related to your complete environment, meaning what are the log levels that you want, where do you store your backups, what are the retention settings, the compression settings, encryption settings, and so on. So everything that is global to your complete installation. And then we have something that we call Stanza part. The Stanza part is where you define your Postgres cluster. Postgres cluster can be one host or multiple hosts if you have primary and standbys. So typically, your PG data path. The stanza is just a name, but the name of the section, the name of the stanza that you will use should be something meaningful for you and not simply localhost or production or so on, because if you move your data to somewhere else to test or restore or so on, you will lose the meaning of where it comes from. So use a meaningful name for you. Here in my example, I just named it my stanza. pgBackRest relies on the point-in-time recovery of Postgres. So you first need to configure the point-in-time recovery, the continuous archiving in Postgres. To do so, you have to enable the archive mode and change the archive setting, the archive command setting in Postgres. Then you're ready to go. First, you have to initialize your repo with the Stanza Create subcommand. Stanza Create will only create subdirectories inside your repo and build some manifests just to make sure all the information comes from the good Postgres cluster. And then we can check that everything is working with the sub check command. The check command will only ask Postgres to trigger a new archive, and we'll check that the archive is coming to the repo. So just checking that the archiving system is working. Our continuous archiving is working, we can take our backup. Backup is pretty easy. It's the backup subcommand with the type of backup you want. After a successful backup, the expire command will automatically be triggered to remove your old backups. So expiration is done based on backups. Which types of backup do we have? The first one is the full backup. It will copy all your database cluster files, and there will not be any dependencies on previous backups. So everything stored in there. And then you also have the possibility to have incremental backups. Incremental meaning we will only copy the database files that has been modified since the last successful backup. Last successful backup, it could be a full backup or it could be an incremental backup. So you could have a chain of multiple incremental backups. To avoid any problems in the chain of backups, you could also have differential backups. Differential backups will only copy the database file that has been modified since the last full backup. So it's not relied on the incremental backups or the intermediate backups. It will only rely on the full backups. So that's the three types of backup we have. Once you have taken your backups, your system is running with archives and so on, you might want to know what's inside your repo. To do so, use the info subcommand. The info command will give you an overview of what's inside your repo, an overview of your backups, when it was taken, what WAL files are related to it, and also the repo is split in two parts, the backups and the archives. So you will know what's the oldest archive in your repo and what's the latest one. You won't know anything in between because the info command is designed to answer fast. So you only have the information based on backup manifest or just the oldest and the latest WAL files there. So it's pretty fast and pretty helpful. Now that we have reminded the basics, we get to answer the question, where do I store my backups? The first recommendation is do not keep your backup storage with your Postgres host, because if you lose your server, you lose your Postgres data, you would lose your backups too. So don't do that. We have two ways of communication with pgBackRest. We could push directly our backups to any repository types that is directly attached to our Postgres host, or use a dedicated backup server. What kind of storage do we support? We support multiple types of storages like cloud, Azure, Google Cloud, or S3, or even a network storage inside your infrastructure like CFS or NFS mount points. So it's various storage types. In case of the storage is directly attached to your Postgres host, you can take your backups from your Postgres host and it will be pushed to your repo. But you could also ask a dedicated backup server to take the backups. To do so, it's pretty easy. You first install pgBackRest, then you create specific system user for that, and you set up passwordless SSH connection between your backup server and your Postgres host. And the communication has to be both ways, because the backups will be taken from the dedicated remote host, but the archives that are pushed by Postgres are pushed from the database host to the backup server. So communication must be working in the two ways. Then comes the configuration part. Here you get the same thing as we mentioned earlier, the global part and the Stanza section. On your Postgres server, the global part will define where is stored your backups. Where it's stored on your repo host, named backup server, for example, and which system user do you define. The Stanza section is where does your Postgres data live? Here it's locally. On your dedicated backup server, same thing. Global part is where do I store my backups? Here I just simply defined a local endpoint named backup space, but it could be on an S3 storage. It could be any storage you want, any storage type that we've just seen. And then the Stanza section. To be able to communicate with Postgres, we need to know where it is located. So what's our Postgres host? Here I named it pgSQL server. And which host user do we use to connection to SSH? So that's always the same thing. First global section is where do we store our backups, and Stanza section where our Postgres lives. So what's the difference between pushing directly every command from your Postgres host and using a dedicated backup server? In any case, archive command is triggered by Postgres itself, so it will always happen from the Postgres server. The backup command is triggered on your repo. I mean, if your Postgres server has a directly attached storage, then the backup command can be run on the Postgres host. But if you have a dedicated backup server, the backup command will run there. And finally, the restore command. The restore command only restore data locally. So you will use the subcommand restore where you want to restore your data. So not on the backup server, but on the Postgres host. So that's for the configuration of one repository. But last April, we introduced multiple repositories. Why? Because we can have redundancy, or we can have various retention settings. Here, the example is pretty simple. We got two local repositories with various retention settings. More full backups in one, less in the other. What's the impact of that feature? We'll have to look at each subcommand that we've just used and see how they react. First thing to know is that there is now a new repo option, a new command line option. It is backward compatible because it's not required when you only have one repo configured. And just a recommendation, but when you have a single repository configured, it's recommended to use repo 1 in the configuration. No, not repo 2 or repo 3, use repo 1 if you only have one. We'll see why in a moment. So have a look at various subcommands that we mentioned. Stanza Create command. Stanza Create will only create subdirectories inside a repo and so on. So if you use it, it will automatically operate on all configured repos. Meaning, if there is already a repo 1 and you had a repo 2, you can rerun the Stanza Create. It will only check that everything is fine with the repo 1 and initiate the repo 2. Check command. Check command is just triggering a new WAL segment from Postgres and tries to push it to all defined repos. So we will wait that the same WAL segment is archived to both repos to make sure the archiving system is working fine. Archiving system is using archive push command. The archive push will try to push the WAL archive to all reachable repos. What happens if one repo fails? If one repo fails, the archive command will fail, so Postgres will not remove or recycle the current WAL file. To bring some fault tolerances, we can use archiving asynchronously. We'll see a little bit later what's asynchronous archiving, but you just need to know that the idea behind asynchronous is to go archiving things before Postgres asks it. So we could archive things in the working repos before Postgres asks it. We'll see that in a moment. But basically, the archive push command will try to push the WAL archive to all reachable storages. And then come the backups. Backups need to be scheduled individually for each repo. If you don't define the repo option, the highest priority repo will be used. Highest priority being repo 1, then repo 2, then repo 3, and so on. Here in the log, you get an example, repo option not specified, defaulting to repo 1. And that's also why we recommend to use repo 1 when you get only one repo. Because let's imagine you use repo 2, take your backup, it will default to repo 2, and everything went fine. And then you add repo 1 because you want redundancy. Suddenly, your command that run usually fine sending things to repo 2 will now send things to repo 1 without you knowing. So it's really better to use repo 1 if you get only one repo. Also, that's important to remember that the expire command is triggered on the backup command. After a successful backup, the expire command will be triggered. And it will remove archive based on what backups are inside your repo. So if you don't have any backup inside a repo, the archives could pile up in that repo and never be expired. So pay attention to it. Now that we took backups, we might need to know what's inside a repo. So basically, if you don't specify the repo option, you will get everything from every repo, and the backups will be sorted by dates. So it will be mixing the repos. It can be a little bit confusing to find out which chain of backups you have, because it will be across multiple repos. Here in the example, we see that we get the oldest while archives in both repos is A, and the latest one is C. If we go deeper and just want to know what's inside repo 2, well, repo 2 says that we get full backup in repo 2 needs only the while backup being C. So we get the oldest while in that repo being C. Why? Because I just said expire works on backups. So it expired A and B because it doesn't need it. So usually, and let's hope you will never have to do that, but you might need to restore. In case of restore, the recovery command, the restore command of Postgres is automatically defined and use the archive get command. The archive get command is the other way around as the archive push. It's basically taking archive from the repo, feeding it to Postgres. Archive get will look inside the repos in priority order. So it will first have a look at repo 1 and then repo 2 and so on. The idea is to have repo 1 the closest to your data, actually. Let's imagine you have multiple repos, but you have one inside your network being in NFS storage and one in the cloud, like an S3 bucket. Well, you might want to define repo 1 being locally in your infrastructure because, yeah, the archive get command will pull archives from there first. So it's easier and faster to have it closest to your data. And it also means that it tolerates gaps, because if it doesn't find a segment inside one repo, it will try to look inside the other one to get it. So it tolerates gaps, and it's a very nice improvement. And that's it for the multi-repo feature. So now we can go a little bit deeper with less common operations. pgBackRest is very handy when you have multiple Postgres hosts inside the same replication cluster. I mean, primary and standbys. Usually when you have a standby server and it's lagging too far behind the primary, you have to refresh it. But you probably don't want to take a new complete copy of your primary. So you could use your point-in-time recovery backups to refresh your streaming replication standby, or even create a new one. To do so, your repository storage needs to be reachable from your standby server, of course. You could add an extra Stanza configuration on the standby. It's recovery option. I'd assume you know how to build the streaming replication yourself, but the most important setting is the primary icon info in Postgres. So you could ask pgBackRest, when you do a restore, add this primary icon info to my Postgres settings. And then perform a delta restore. Of course, if your primary is more than 1 terabyte, you don't want to copy over 1 terabyte again. You probably only need the last few days. So you could use delta restore to only get back the data files that has been modified, compared to, of course, what you have locally and what you have in the backup storage. If you are creating a new streaming replica, you don't need the delta option because your data directory will be empty, but the delta restore is pretty handy to refresh an old standby. So using the restore command with delta option with the standby type will add accordingly standby mode or standby signal file. So using that command, we'll simply restore point in time recovery backup, add the primary icon info, add everything needed for the standby section, and add the restore command. Restore command being we'll replay all the WAL archives until the end and then try to connect to the primary using the streaming replication protocol. So it's pretty easy and pretty handy. But what if we have primary standby? We might want to take backups from the standby. Well, it's easy. We get a backup standby option to do so. But then we need in our Stanza section to define our locally running standby, so our pgdata file, but also define where's our primary, being pg2 host here is called primary and what's its path. Why? Because when you take a backup from standby, first the backup started on the primary using pgstart backup. We will get there what's the WAL location, and we will await that the standby has actually reached and replayed that same location before starting to copy the files from the standby itself. So it's kind of hybrid situation because we have operations going on the primary, but the actual files will be copied from standby. And it's even more handy because pgBackRest is able to detect itself which one is primary and which one is standby. So imagine you have an high availability setup, like using patch routing or something like that. And you get a dedicated backup server. Defining your Postgres nodes, pg1, pg2, pg3 there, and you want to backup from standby. You won't even have to change your configuration in case of failover, because if the standby is promoted, it will no longer take backups from there, but from another node. And pgBackRest will be able to detect automatically which one is standby, and so from which server to pull the backup. So it's really handy to have a dedicated backup server in case of failovers and so on. So you don't have to reconfigure your backups or your cron tabs in case of manual failover. So that's for handling standby servers. Now comes the archiving system. So the archive push command is triggered by Postgres inside its archive command setting. If you use asynchronous archiving, we will in fact, when Postgres asks to archive one WAL file, an extra processes. If you use multiple processes, an extra process will look at Postgres which WAL files are ready to be archived, but not requested yet, and try to archive it already, so being ahead of Postgres. And when it's done successfully, we will write in a spool path an acknowledgement file, just temporary data saying, okay, I've been archiving this one. So when Postgres will require it, will request to archive that wall, it will already be done. And backrest will be able to simply say, okay, so it's speeding up the archiving system by using multi-processes. The more processes you have, the more WAL files you will archive simultaneously. That brings us to the fault tolerances of the multi-repo feature, because each time Postgres will ask an archive, even if it's blocked on one repo, the async process will still fetch what is ready to be archived and push it to the repo that is working. So archiving asynchronous is really handy and really fast. So it's really helping in case of big activity. But what if your archiving system is blocked when Postgres will keep its archives? So it could, at some point, block Postgres itself, because if you run out of disk space, Postgres will stop. So there is an option named archive push queue max, which is actually the maximum size of Postgres archive queue you want. Let's say 10 gigabytes, for example. When you will have 10 gigabytes of WAL files ready to be archived, more than 10 gigabytes, well, pgBackRest will in fact tell Postgres the archive command was successful, but it will not push the archive, because probably your archiving system is blocked, your repo is full or not reachable or whatever. So it will unblock the situation from the Postgres point of view, but it will generate missing archives in your repo. So it's handy to prevent any production problem, but it can corrupt your archive chain. So it's very, very important to monitor your archiving system, your disk space, and ensure that everything is working fine, because you could have missing archives. Use that setting with a lot of precaution. I don't really personally like it, but it can be handy in some cases. And then the other part is archiving get, so the restore command of Postgres. If you use multi-processes and asynchronous processes, the idea is to speed up the recovery by already prefetching a certain amount of WAL segments from your repo to the local spool path. So it's usually best to keep the spool path next to your Postgres WAL directory in the same disks. Let's say you will restore and trigger archive gets and so on, but your repo is an S3 bucket, it's pretty slow, it's pretty far. You could have multiple processes already prefetching the WAL segments locally from the S3 buckets before Postgres needs it for the recovery. So it's pretty handy to speed up the recovery. And finally, in this section, a pretty handy trick too is the selective restore. In case you have a big cluster with multiple databases, and sometimes you only need to restore one database to extract some data there and reject it afterwards in your Postgres data, well, you can use a db include option. db include option is only restoring the included databases. The other one will be restored empty. The built-in databases, the system databases like Postgres, will always be restored unless you exclude it specifically. So that's when you need to only extract one database. But if you want to extract all your databases except one, you can use db exclude. db exclude will restore the empty database that you excluded. And when you combine db include with db exclude, well, db exclude will only refer to the built-in databases, meaning I want to include MyDB and exclude Postgres. Why do we restore it as empty and zero in files? Because you will need those files for the recovery. But once the recovery is complete, the databases won't be reachable. So you don't need it anymore. And if you want to keep running with that cluster, you need to drop database to remove those empty databases. Of course, if don't do that in production, do that for extracting data that you need to re-inject in production, but that's not really intended to do in production. So pretty handy when you have multiple databases inside the same cluster and that they are pretty big. So now comes the diagnostic part. The first interesting thing in Postgres or in backrest to prevent data corruption is checksums. Fortunately, currently the data checksums are enabled when you create a new cluster at the EDB time. My recommendation is when you create a new cluster, enable data checksums. We get this nice tool named pgChecksums in Postgres that enable or disable or even check data checksums only when your cluster is offline. If your cluster is pretty big, it can take time to bring it down, check the checksums and so on. That's not pretty handy. But once your checksums are enabled, pgBackRest will be able to automatically enable database checksums validation while it's taking the backup. We are copying data, so why not checking checksums at the same time? If there is a checksum error, you will get that into the backup log. You could also see in the info command, if you specify the option --set and your backup set, you could have a bigger summary than the one I've presently shown. And if there are checksums errors, they will be shown there too. So that's pretty handy if you have checksums enabled. Backrest will be able to check it while it's taking the backup. I often see also a misunderstood feature, a misunderstood command. The check command doesn't check your backups. It checks that your archiving system is working by calling a create restore point inside Postgres and asks it to pg_restore also to generate a new archive and make sure the archive comes up in the repo. So the check command doesn't check your backups. Sometimes when you get archiving, system failing, and you need more info, well, you get multiple levels of logs. The first one is the console log. When you run the command yourself, in the command line, you will see console output. And for some commands like backups and restores, you get a log file. So in the log file, you could have more information. But the archive push command is triggered by Postgres itself. So it doesn't have really a Postgres log file for itself because the console output will be sent to the Postgres logs. So if you define a log level for your console pretty low and don't want too much info, you might need to add some extra debug option just for your archive push command. That's pretty easy to do in the configuration. You just simply say in the global section for the archive push command, just apply the setting log level console equal debug. That will send debug logs to the Postgres logs each time the archive push command is used. So it's pretty handy. Archive push has log file for itself when it's using asynchronous. The asynchronous processes will push to the log file because it doesn't have any console, since it's triggered automatically asynchronously. So archive push is a little bit tricky to debug because you have at some places you have the Postgres logs and you have the async logs. So 2 places to check. So how could we check our backups? Well, there is a work in progress with the verify command. It's internal only for the moment because it's work in progress, but the idea is to go through the backup manifests and check on disk if the checksums are correct. For the WAL files, for the backup files, So if there is missing pages from the manifest on disk or a checksum that is invalid, they will report. It should also report missing archives, but we'll see in a moment that it's not working yet, and I'll explain why. The best way to know if something is going wrong is monitoring. Don't forget the Schrödinger's law of backup. The condition, the state of any backup is unknown until you attempt a restore. We've seen that we can get more information about what's inside your pgBackRest repo using the info command. You could go a little bit deeper and construct your own summaries by using the JSON output. So using, for example, JQ for getting some more information. Or you could use the Nagios plugin I wrote named Check pgBackRest. Check pgBackRest will help you whatever the backup location, because it will use internal pgBackRest commands like the info output with the JSON output and the repo commands to get to the repo and see what's on disk. Because currently the verify command doesn't go on disk, it's just checking the manifest. It has a nice retention service. A retention service, when you define retention settings in Backrest, you ask, let's say you ask for 3 backups and take the first one. You won't have an error saying, oh, I only have 1, I should have 3. It's the first time you take a backup, that's normal. But you don't know. So you might need to have an alert or some kind of warnings to know that you have at least some amount of full backups, or that your latest backup is not older than a certain time, or the latest successful full backup is not too old. So to check that, you can use Check pgBackRest. It has by default a Nagios output format, but it also has the nice human output to give you a summary. So you can run the tool manually to get more insights of what's inside your repo and check if you have enough full backups. You can mix multiple arguments together. So I want at least 1 full backup, less than 24 hours for my last backup, and the last full backup must be not older than 7 days, for example. You could do that. And then we want to check the archiving system. I've said that the info command only shows the oldest and the latest WAL files on the repo. It won't check anything in between because it has the answers fast, and there could be a lot of archives there. It could take time to check it one after the other. So the info command won't. And currently the verify command is only experimental, so in development status. Check pgBackRest will be able to go to disk using the repo commands internally from pgBackRest itself, check what's in there, then get you some kind of summary. What's inside the repo? Is there any missing archive or not? If you build your own system, pay attention that you can encrypt your repo, and you need to know what the encryption key is. So using the internal commands like repo ls or repo get can be handy, but you need to know the internal commands of pgBackRest to do so, and Check pgBackRest is delivering these commands. Good example. Let's say we will remove a WAL archive from the repo. The info command won't report it. We remove the 5, and it only says we got 3 and 6 inside the repo, but it doesn't detect the 5 is missing. And the verify archive command is not telling that it's missing too. So pgBackRest won't report an error yet. Check pgBackRest will, at least at 2 different levels. You will get a critical alert if the missing archive is after your last successful backup. Why? Because you would be able to restore your last backup, but not reach the now. Not reach now, because there is one missing archive. You could restore until your missing archive, but not later. It will raise a warning if the missing archive is before the latest backup. Why? Because, of course, you could restore the last backup and replay all the WAL files until now, so your point in time is not really broken. But there is some missing pieces between your last archive, at least between the missing archive and the last backup. So there could be gaps, but the point in time recovery until now is not broken. And so voila, that's basically it. You could have a lot more information on the official website. There is a big list of all the settings, what they are doing, and so on. There are official user guides for Debian and for Red Hat. The code is, of course, open source. Regarding user guides, you can also find useful tricks, useful use cases on my personal blog post. And check pgBackRest is also an open source project on GitHub. And of course, thanks to our great pgDG community, the packages for both pgBackRest and check pgBackRest are inside the pgDG repos. So in conclusion, Backrest is very powerful. It will help you with a lot of features, meaning multiple repositories, selective restore, asynchronous archiving. Well, it's pretty handy and with a lot of features. But don't ever forget the Schrödinger's law of backup. And the best advice I could give you is monitor your backup, your archiving system. That's really, really important. Anyway, thank you all for your attention. And voila, I've done for today.
Okay, thank you very much, Stefan, for the extensive overview. And we have plenty of questions, if I'm not mistaken.
Yeah, we do. We do, actually. So it was lots of details, and lots of details cause lots of questions. Let's start with YouTube chat.
There's yeah, all right. There's also a very light question available on Slack.
Let's start with that.
To start with it, yeah. One of our listeners asks, it was always interesting, why did you choose the term Stanza for the utility? Why was it chosen as the name?
Well, it really depends on what usage you do of your Postgres cluster, in fact. What data do you have there? Is it a website? Is it a specific application that you have developed inside the company? It's just using a meaningful name for you. For my demos or my tests, I usually use demo or my Stanza or something like that. It's just for testing purposes. But in production, usually you get something meaningful by your cluster, your Postgres cluster current function, actually.
I think actually the question was why this strange name Stanza? What does it mean?
Oh,
yeah.
I don't really know where it's come from. I think it's come from Latin, but yeah, it's just yeah,
it sounds Italian.
Yeah, that's something like that. I think it means cluster or something like that.
Okay. It was probably some nice name picked up by David.
Yeah,
I think so. And I think actually he explained something like it should be different from common terms, like cluster is reserved for many things in Postgres and always confusing. What does it mean? But I'm not sure.
I think he explained that in your Postgres TV interview.
Yeah, something like this. If I
just to let the audience know, but behind the tool there are multiple persons, but also Crunchy Data, and with David Steele, Stephen Frost, Cynthia Chang, there are multiple contributors behind that tool. I've been recently helping them So I'm one of the contributors now. But yeah, the original developers are Stefan Fercot and David Steele. So yeah, there was a very interesting session by interviews with Ilya some time ago in Postgres TV. And yeah, I remember that was a question too. Why Stanza? Because all the names were taken, basically.
Yeah. More
Yes.
technical question. Do we really need to call pgstart backup on the primary for non-exclusive backup that exists since 9.6?
Well, I'm not sure we absolutely have to, but we want to, because we want to make sure that the standby server has catch up with the primary and that the database files has been synced by the checkpoint locally on the standby server before copying the data to the backup. So we have a backup inside the repo that reflects where the primary was at the start of backup. So that's why that's chosen to take the start backup on the primary and not the standby, because that way we are making sure in sort of that we are at the same stage as the primary is.
Mm-hmm. Yeah.
But indeed, I'm not sure pgstart backup couldn't be executed on a standby server directly, but yeah, that's not the goal.
Great. That was a small discussion about point-in-time recovery, which probably we can skip now and ask the question from Slack. Is there, because partially that question was already answered by others in the chat. Is there any plan to add table of backups, like a list in database? There is the text one, there is the JSON one, but do you plan to add something which looks like a table because it's more convenient to query?
Table like in Postgres, you mean?
Yeah.
Well, you could do that. I think there is an example inside the user guides by how to load the JSON output from Postgres and handle it like a table. You could do that, but I don't think we will add an extra output format for the info command. Of course, it's an open project, so if someone wants to try it and develop it and suggest it and submit it, it's welcome. But well, since we can actually trigger the info command from inside Postgres and play with that inside locally, not sure it's really important to do that.
Okay. There's another question. Do you have plans to add database information to info output JSON? For example, -- output JSON stanza demo set backup name. Currently, information is only available for output text option.
Well, I'm not sure of the question because the info command is basically using the same information and just parsing it, outputting differently. But I'd had to check. Of course, same thing. If that's something someone needs, just raise an issue or ask it and we can have a look at it.
Yeah. So I think the person who asked this can go to Q&A session and ask that in details.
I know we can add some more information inside the info command. For example, I know that currently a good example is the checksums errors. The checksums errors are only shown at the backup set level. So you have to force the backup set level in the info command to get the checksum reports. We'll plan to, I don't know when, because of course it's an open source project, so we have a lot of going on, but there is a card in the project board to add more information about the checksums directly into the big summary and not inside a specific summary.
Yeah.
So yeah, there will be a lot of improvements on the info command. We can make plenty of improvements, but the question is always choose the best priority.
And probably it is good to give feedback from the users. If you want developers to make something, just explain them why you need this, what's your use case, and so on. They usually listen.
Yeah, the GitHub project is a good place to do that. And for newcomers who would like to have contributions and would like to help, the info command is actually a good starting point, because it's not the most complicated command to see how it's working and to get multiple output formats and so on. It's perhaps a good starting point if someone wants to make a first contribution. The contribution guide has been updated lately, so yeah, it should be helping.
The question about point-in-time recovery, which was discussed in chat and not cleared quite. I didn't quite get, that's the question, I didn't quite get the part about point-in-time recovery backups. Can I restore at any time in the past, or only at a moment then the backup was created? Which is...
Okay, so that's basically how Postgres works. Postgres works as two parts. The first part is the base backup, so the backup of your data. If you take it while your database is running, you will need the archives between the start point and the stop point of your backups to reach a consistency point, because currently all the transactions that are happening on your running cluster will be written inside the WAL files and reach the archives. So the first thing to know is when you take a backup, you can restore that backup, and you at least need the archives generated between the start point and the stop point to get a consistent backup. So that's the first thing. And then we have continuous archiving. So that's why we set up the archive command in Postgres. The archive command is running all day long, not only while you're taking a backup. So at any point of the day, you would have archives. Every transaction that happens to your cluster goes to the WAL files. So you could, let's say you take a backup at 11 p.m. and we are now 7 a.m. You restore the backup. You replay the WAL archive. Postgres replays it itself, but Postgres will replay the WAL archive until the consistency point, and then you specify the target you want to reach. So now 7 a.m. So it will replay, or it try to replay all the WAL files it needs until the target is reached. So it's pretty up to us to know where to stop. If we want to go before a drop table or something, it's usually pretty hard to find the good target. But if at a specific time, it's pretty easy to reach that time, given you don't have any missing WAL file. Because of course, you have your base backup, you have your archives to bring that consistency. If there is one missing archive there, your backup is not consistent. So that backup is useless. If you have all your archives there, backup is consistent. Then you have the continuous archive for the day. Let's say we are now 10 p.m. here, 10 a.m. here, 10 a.m. Let's say we have a missing archive at 7 a.m. this morning. Well, you won't be able to get to any point between 7 a.m. and now, because there is a missing archive at 7 a.m. But you could go until 6 a.m. That should be fine, because you have all your archives. So that's why it's so important to have a monitoring of your archiving system, because yeah, you have the base backup and its consistency, but you need your archives if you want to restore to any point in time between two backups. Well, I hope that answers the questions.
Yeah, I hope as well.
It's usually better to explain it on a whiteboard and with drawings and so on.
With timelines, yeah.
Yeah.
And another question which we have, is it possible to make some sort of detached restoration of the database as a snapshot without a repository? So basically make some sort of archive and then move it to just another cluster and there restore it? Or you always need entire repository to do this?
You don't really need the entire repository, but you need the manifests that's inside it. That's the most difficult point. Actually, inside the repository, you have manifests. So you have one manifest per bucket, but you also have one global manifest. And you could use some options like archive copy to actually, at the end of backup, copy all the whole archive the backup needs inside the backup directory itself, which usually is not done because you have two directories, one for archives and one for backup, but you could specifically ask to get your archives there. But using backrest to restore it, if you don't have the backup manifests, the global manifest is pretty hard. So if it's in the manifest, it should go fine. If not, that could be difficult. So usually we don't tend to copy things from one repo to somewhere else. We try to recommend that the test server or whatever can read the repo on read only. So it can get data from there, but not push any wrong archive there. I know that we are planning some time to be able to take backup or restore a backup to outside the repository, specifying a specific location for that backup to be taken or to be restored from, but we are not there yet. Currently, we need the repo because of the manifests.
Clear. So
even if it's partial, I mean, even if you only have, let's say you have 3 full backups and you want to copy only the last one, if you have the backup manifest, the global manifest, saying you have 3 isn't a problem if you specify it afterwards, but you need those manifests.
Yes. Probably the last question, because we're running out of time, before we move Stefan to the our corridor to ask further questions. So the question is, are you considering a partial backup, not only partial recovery? So it's a slightly strange question from my point of view, but anyway, so can you back up a single database on the cluster?
That's against the Postgres rules, so I don't think so.
Yeah.
Yeah, basically the WAL files are covering all the databases inside the cluster. So yeah, we couldn't take a partial backup from, we could, but it would have any point.
Yeah, it would be like very strange from the security perspective, actually.
Well, it's at some point we have in Postgres wildfire that are only related to any database in the cluster and not the cluster, the entire cluster itself. Perhaps, but we are not there yet in Postgres. So
yeah, so it make actually no sense. Okay, then let me say thank you, Stefan. That was like very, very informative talk, and amount of questions is self-evident. I think some people will have more questions, so we move you to a separate QA zone to answer them if there are some. And thank you again. Thanks for coming.
Thank you for listening.
Stefan.